Now that I know it's working, that the traffic between VLAN 2 and VLAN 3 is working via this gateway, let's analyze how this actually works. So the first step, let's say when I'm pinging from PC1, which has a subnet IP address 10.1.2.0, and it tries to get to 10.1.3.0, my PC realizes that the recipient is not in the same subnet. In that case, it needs to use the default gateway, which currently is configured on R3 with the IP address 10.1.2.3. So what it does, it realizes, okay, the packet is from 10.1.2 to 10.1.3 subnet. I need to send it to my gateway at the layer 2. So in order for that to happen, it needs to first send the ARP request and checks my default gateway address is 10.1.2.3, so who is 10.1.2.3? It sends the ARP request saying it's a broadcast, so the unicast MAC address of PC1 in the source Ethernet MAC address is placed, and then in the destination field we see the broadcast, all Fs. Inside there's a question. My name is 10.1.2.101. I'm asking for a MAC address for 10.1.2.3, which is over here. The traffic enters the switch number 1 and it enters the interface E12, and it's a broadcast. So let's jump over here real quick and check the MAC address table. Show MAC address table interface E12. So the traffic arrives on interface E12, which is now currently in VLAN 2. And the question is, who is 10.1.2.3? Please provide me with your MAC address. This traffic is broadcast, so will be flooded out of all ports belonging to VLAN 2. It means that it comes to the PC2, which is also VLAN 2, but PC does not have IP address 10.1.2.3, so ignores that. The traffic also is sent across the 4.0 because it's a trunk port. Show interface trunk. It goes out 4.0 because the VLAN 2 is allowed, and it enters switch 2. Switch 2 receives tagged frame because obviously switch 1 needs to tag it with the VLAN 2 before sending this out towards switch 2. Switch 2 knows it comes from VLAN 2, reads, oh, it's a broadcast, I'm going to send it to everyone in VLAN 2. Now there's only one port, 2.1, and obviously that one says, oh, I'm not 10.1.3.0, so it ignores that. But now that we've configured this port as trunk, the tagged frame is going to be sent out that port and enters the router ID. And the router is asking itself, am I 10.1.2.3? Let's jump to the router real quick. And there is an interface, show run, the sub interface E02, interface E002, which has IP address 10.1.2.3. That interface receives the tagged frame, so it's actually E00 that is receiving it, but it is being processed by E02 and saying, okay, I am 10.1.2.3. And the frame is tagged, and the tag is read aloud on that sub-interface with this command. So it says, okay, I am 10.1.2.3, and it responds back out the same interface with the ARP reply. Now it enters that, since it's being tagged with VLAN 2, it enters as a tagged frame ARP reply to enters the port E02, and is sent to the port E12 because the router knows who asked the question. Meanwhile, router is going to create ARP cache and is going to remember who asked the question. It's right here. And now it's sending information about this MAC address. Let's copy that. And in the PC1, we should see this association between 10.1.2.3 and this MAC address right here. So let's see that. So now PC1 knows how to reach the gateway at the layer 2. Show IP ARP. And this MAC address here matches exactly the gateway MAC address. So now the traffic can be sent towards PC3, the ping packet. So it is encapsulated, its ICMP protocol, into layer 3 with a source IP 10.1.2.101, destination IP 10.1.3.103, but at the layer 2 the MAC address of a sender is MAC address of the PC1 and MAC address of the receiver is router 3 according to this ARP cache right here. The packet is delivered at the layer 2 with the source MAC of PC1, MAC address of the router 3 gateway as a layer 2 destination MAC, is being processed now by this interface. So this layer 2 is stripped off as soon as router 3 realizes he is the destination of that conversation. And then it looks at the layer 3 in which it sees the 10.1.2.101 sender and the receiver 10.1.3.103. Since we created subinterface, that creates a routing table directly connected to E00.3 with the address 10.1.3.0 subnet. Let's see how that happened. If I added those show IP route 10.1.3.103, how would I send the packets out? I would send the packets out the interface Ethernet 0/0.3 because that is directly connected to that subnet with this configuration 0.3. That creates an entry in the routing table directly connected. We can see that show IP route connected. So we have this network connected on the interface E03. What happens then? The packet is moved from the Ethernet 02 to Ethernet 03 and it needs to be encapsulated into layer 2 frame. So the source MAC address is the MAC address of this router interface 0.3. Destination must be directly connected. The destination MAC address must be for 10.1.3.103. Router is asking who has now sent the broadcast from VLAN 3 to all VLAN 3 devices like discussed previously. Who has 10.1.3.103? Only one has. So the tagged frame arrives here. It's sent only here as tagged. Tag is removed, enters the VLAN 3, the only port here. And this guy says my MAC address is this and sends this back out to E20. It's going to be sent via this interface, so the tag is going to be introduced into the frame. Tag for VLAN 3 enters here. The MAC address of the device that asked the question is associated with this interface, E02. Sent across, tag is preserved, sent to the router. Router makes a note. Okay, I know what the MAC address of 10.1.3.103 is right here. And so now it can create a layer 2 frame with a source MAC of a router 3, destination PC3, and it goes down here as tagged over E0.0.3, sent over here as tagged, tag is popped and enters the router, the PC3. And obviously the opposite conversation works the exact same way. Another way of doing this routing is to use the layer 3 capability of those switches, but that's going to be the next video.